All right, let's take a look at this graph. First thing I do when I see a graph is look at the axis labels. So I have distance in meters, starting at 0, going all the way to 320 meters. And on my x-axis, I have time. Now, the title of the graph is called The Movement of a Zebra. So we can assume that starting at 0 seconds, if I was watching the zebra, it was at 0 meters. So that's our starting point. That's why there's a number 1 there. After 20 seconds, the distance is now 40 meters. That's because it was walking, right? So it looks like it had a consistent line here going up. So from 0 to 40 meters after about 20 seconds. From 20 seconds to 40, there's this flat line. So we're still just at 40 meters. That's because he stopped and he was eating. So he wasn't moving. Therefore, he didn't increase his distance away from where he started. Now after 3, you see this really steep line. What does that mean? Well, from, looks like 40 to 60 seconds, so 20 seconds, he went from a distance of 40 meters to 280 meters. So that must mean the zebra was running because his speed was increasing compared to this time, right? This line is way steeper than this line. So if you remember, our speed is calculated by distance over time. Distance over time. So what we're going to learn about is how we can describe motion or describe speed, describe how things are moving by looking at graphs. So first, let's just go over some basics, just to refresh your memory. There are 3 different types of graphs: bar graph, line graph, pie graph, right? This is a bar graph, right? We've got bars. So it compares categories like locations in this example. In this graph, it says damage to a cell phone when dropped. So different locations, different categories. You can do time in a bar graph, but usually it's like, for example, how many people have a birthday in that month. So it'd be like January, February, March, and you would have, 2, 4, or 5 people, for example. This is a pie graph, right? Looks like a piece of pie. So this typically shows a percentage of data. This is a line graph. So this shows the relationship between 2 variables. For example, cuteness versus number of legs. It's a joke. Poor spiders. But you can see there's usually your x-axis is numbers. You might have categories or numbers on your y-axis. Now, we usually in science will make line graphs. So let's look at each piece of the line graph. So every graph has the following pieces. You have your title, right? That describes the information that the graph is telling us. You have your x-axis label, not the unit, the label. So this is the measurement, and it'll tell you what the unit's going to be. And that always goes in the bottom, x-axis. Then you have x-axis scale. That's going to be like your number unit. That's where you're going to look to see, okay, 1990 at 57%. So that's your unit. It's a range of numbers that the x values fit between. Then you have your y-axis, which is your side of the graph. This is your label. So in this case, it's percentage of households with cable television. And then this is your y-axis scale. It's a range of numbers that fit between. Looks like this case, 53 and 74. Well, what are these dots? These are actually your plotted points. So these are numbers taken from a data table, and then they're plotted on the graph. So for example, it looks like this is on a nice location. In the year 1990, 59% of households had cable television. What's this line? That's called the line of best fit. So it's a smooth line showing the general shape or trend of the data. It's almost like you're trying to connect all the dots, but you're not going to do it in a way that you're going to go, touching all the dots. You're trying to find that middle point to show people this is generally what the data shows. Alrighty. So in making graphs, the independent variable belongs on the x-axis, the bottom. So in this case, the independent variable is temperature in degrees Fahrenheit. And remember that independent variable, that's what causes the change. So in this graph here, we see temperature and number of ice cream customers. So we're going to assume because the temperature is the independent variable, the temperature of the ice cream is going to determine how many people will buy it. When you're looking at a data table, the independent variable is going to be on the left. See how it says X? So all these plot points were plotted on this graph. There's no line of best fit yet. So let's look at your dependent variable. Your dependent variable belongs on your y-axis, your side of the graph. So remember, this is the variable that gets measured as the result. It's the one that's being changed by the independent variable. So the number of customers that buy ice cream depends on the temperature of the ice cream. When you're looking at a data table, the information is on the right side. So just remember your y-axis on the side, that's your dependent variable. Your x-axis is the independent variable. And if you remember from last unit, we called the independent variable the hammer because it causes change to the dependent variable, which is like a nail. So if you can remember the independent variable being the hammer is what's causing the nail to change. All right, so how do you set up a graph? Well, first, don't forget your labels, right? You have your title, which usually isn't anything fancy. In this case, it's just kind of repeating what your variables are. So your independent variable is temperature. The dependent is number of customers. And you don't have to have the same scale, obviously, for your independent and dependent, right? In this case, that wouldn't make sense. When you're creating the scale, you find the largest number you need, and that you'll get with your data table. So apparently there was no ice cream that went above 85 degrees Fahrenheit, right? So that would be your largest number, and then you would divide it to have an equal number of spaces. So let's say this was your lowest number. You can see they just easily went up by 5. All right, so now I'd like you to complete the graphing basics questions. There's not very many, but it'd be good practice for you. Remember, this is only open today, and you'll only get points for it today. If you don't do it, it's not going to be a 0, but it's just not going to help you.